Welcome to the deep dive. Today we are looking at, well, a massive leap in AI orchestration.
Right, the release of Claude's new Opus 4.8 model and the introduction of dynamic workflows.
Yeah, exactly. And we have a stack of really fascinating sources in front of us today. We've got real-world stress tests from three AI automation creators, Nate Herc, Mansell Scheffel, and Eddie Chen.
And we're also looking at that deeply technical breakdown, the scaling ladder of AI orchestration diagram.
Right, so our mission for you listening today is straightforward. We want to cut through the industry hype, dissect exactly how AI is moving away from those single chatbots we all use daily, and look at these massive swarms of parallel agents.
Yeah, and more importantly, figure out when you actually need to deploy this kind of heavy firepower.
Because, I mean, the scale we're talking about here is almost hard to comprehend.
Oh, it really is.
Like, imagine hitting enter on a single prompt, stepping away from your computer for just 30 minutes, and coming back to find that your AI hasn't just answered your question. It compiled a script, spun up over 100 independent agents, burned through 5 million tokens, and, ate through half of your entire $200 monthly budget, all in the time it took you to drink a cup of coffee.
It is the absolute definition of having supercomputer level power at your fingertips. But, I mean, it comes with the very real risk of liquidating your API credits if you don't understand the underlying mechanics of what you just unleashed.
Yeah, no kidding. So to understand why a system would even need to spin up 100 agents, we have to look at the engine powering them, right?
Let's start with Opus 4.8 itself.
Okay, yeah.
From a pure specification standpoint in our notes, it costs exactly the same as the previous 4.7 model, but it operates, what, 2.5 to 3 times faster? Yeah, 2.5 to 3 times faster. And the speed is obviously a necessary prerequisite for the swarms. But the foundational upgrade, the thing that makes autonomous workflows even possible, is this new built-in guardrail they're calling honesty.
Honesty.
Right. The model is now engineered to aggressively evaluate its own work and flag uncertainties before it outputs a response, which significantly reduces the chances of making unsupported claims or, generating fake statistics.
Wait, I need to challenge that a bit.
Yeah.
How can a large language model be honest? I mean, at its core, it is just a probabilistic math engine predicting the next token, right?
Right.
We've all chained prompts together, and we know that AI can confidently hallucinate entirely fake citations. So how does a math engine evaluate its own certainty?
It's a great question, and it really comes down to how the model interprets its own internal probabilities.
Okay.
So in older models, if the probability of the next word being correct was only 51%, the model would still generate it with the exact same authoritative tone as if it were 99% sure.
Oh, so it just masked its own uncertainty.
Exactly. It
Yeah.
masked it. What they've done with Opus 4.8 is implement these training interventions that force the model to actually look at those internal probability scores, the log progs.
Right.
And if they fall below a specific threshold, the model is required to inject language indicating doubt or simply refuse to answer altogether.
So it acts as an internal circuit breaker before the hallucination ever makes it to the chat window.
Exactly like a circuit breaker.
Which makes total sense if you are going to let it run 100 tasks without a human double-checking everything. But, that still doesn't explain the need for multi-agent workflows.
Right.
Because we have this blazing fast Opus 4.8 model, and it has a 1 million token context window. I mean, that is the size of several thick novels.
Yeah.
Why can't I just ask it to do complex reasoning, search the web, write code, and iterate all inside one massive chat session?
Because of what we call the context problem, specifically attention dilution.
Attention dilution.
Yeah.
Unpack that for us.
Sure. So even with a massive 1 million token ceiling, a single main chat session becomes polluted incredibly fast.
How so?
Well, when you ask an AI to write a complex Python script, search the web for documentation, debug its own errors, it generates a massive amount of intermediate work.
Right.
All of that scratchpad reasoning, the failed tool calls, the raw HTML from web searches, it all gets dumped directly into the main context window.
So the window just fills up with junk.
Exactly.
So even if the model technically has room for more words, its attention mechanism, like its ability to focus on the original instruction, it gets diluted by all the trash data it generated along the way.
You nailed it. The LLM is forced to reread its own messy, failed logic over and over again with every new prompt.
Oh, wow.
And at a certain scale, it just collapses under its own cognitive weight. It loses the plot, forgets the original formatting instructions, and the whole system essentially grinds to a halt.
I think of it like a human manager trying to keep the intricate minute-by-minute details of a 100-person engineering project entirely in their own head.
That's a great way to look at it.
Right. Because if that manager has to remember every single rough draft, every single deleted email, every minor bug fix,
Mm-hmm.
eventually they just lose track of who is doing what. The
Mm-hmm.
manager is completely overwhelmed.
That is the perfect way to visualize the bottleneck. The LLM, acting as the manager, becomes overburdened. It has to track intermediate states, manage requests, remember what needs to run next, and hold on to all the reasoning before delegating the next step.
So if the manager's brain is full, the system has to delegate.
Precisely.
And this brings us to that diagram from the sources, the scaling ladder of AI orchestration. Let's walk through how this delegation actually works in practice, starting at level 1, which the sources call skills and subagents.
Yeah, so skills are just reusable recipes. If you have a specific way you like your emails formatted, you save it as a skill. But subagents are where the architecture really changes.
Okay.
Instead of doing the work in your main chat window,
Yeah.
your main Claude session delegates. It spins up 1 to 5 completely isolated, fresh background sessions to handle a task.
And the mechanical advantage here is that these subagents do all their messy scratchpad reasoning in their own isolated bubbles, right?
Exactly.
If a subagent has to read 60,000 tokens of web data to find one specific statistic, it doesn't dump all 60,000 tokens back onto the manager's desk.
Right. It just sends back a clean 500 token answer to the main chat. The manager's context window stays pristine.
It solves the pollution problem.
It does. But subagents have a hard limitation. They do not talk to each other. They only report back to the main LLM.
Ah, got it.
So if you are doing something complex where the agents need to collaborate, you have to step up to level 2 on the ladder agent teams.
One of the sources actually described agent teams like a corporate war room. You have a small crew of specific agents, maybe a researcher, a writer, and an editor, and they actually share a task list.
Yeah, they have their own shared context window, and they can debate and pass work back and forth to reach an end goal.
Which sounds great.
It is highly effective for localized tasks. But notice the structural flaw that remains. Even in that war room, the overburdened LLM manager is still playing babysitter.
Because the main LLM is still the one reading the debate, managing who speaks next, and holding the state of the project in its memory.
Exactly. Which brings us to the top of the scaling ladder, level 3 dynamic workflows.
Okay, so if level 2 is still babysitting, how do we fire the LLM from the manager role entirely?
We fire the manager by replacing them with a factory conveyor belt. And that conveyor belt is a physical, deterministic JavaScript file.
Wait, really?
Yeah, when you trigger a dynamic workflow, Claude completely changes its paradigm. It doesn't just start chatting, it evaluates your prompt and then writes a literal workflow.js script in the background. That script takes over the orchestration.
So the AI writes code, and then the code becomes the boss.
Yes, and that shift from natural language to code is everything. The JavaScript file holds the state of the project.
I want to clarify that for you listening, because holding state is a term that gets thrown around a lot. What does that actually mean mechanically?
Holding state basically means acting as a permanent memory clipboard.
Okay.
Instead of the LLM having to waste its token space remembering that, say, variable A equals 10 and variable B equals 20 across a massive multi-step project, the JavaScript file simply stores those variables in its code.
So the script manages the loops, the logic, and the routing.
Exactly. The LLM is no longer trying to think about what step comes next. The LLM is just a worker stationed at the conveyor belt, executing whatever isolated task the JavaScript file hands it at that exact moment.
That shift from unpredictable natural language reasoning to lightweight deterministic code, that is what unlocks the massive scale we talked about in the hook.
Oh, absolutely.
Because a script is running the show. The sources note this system can support up to 1,000 agents per run. You can have 16 of them working concurrently, fetching data and writing reports at the exact same millisecond.
It's incredible. And because the state is held in the code, it utilizes something called a journal.
Right, the journal.
The journal gives you resumability, which is vital when you are running tasks this large.
Because you don't want it crashing halfway through.
Exactly. Because the state of the workflow is managed by a structural journal rather than a fragile chat window, you can literally pause a massive 500-agent data migration mid-run, turn off your laptop, and resume it 2 days later exactly where it left off. The script just checks the journal and fires the next batch of agents.
Okay, so now that we understand the mechanics of how a system can juggle 1,000 agents without hallucinating or crashing, we really need to look at what these swarms actually do.
Yeah, let's get into the use cases.
The sources draw a fascinating distinction between depth versus width when comparing this to older AI capabilities. Like, Claude already had a feature called slash goal that let it work autonomously for long periods. How is a JavaScript workflow mechanically different from that?
It all comes down to sequential versus parallel execution. The older slash goal feature is about vertical depth. It is a relentless, single file loop.
Right.
You give the AI a complex objective, and it takes one action, checks a single criteria, essentially asking, does done equal true? And if not, it moves to step 2. It can run for 24 hours straight, but it is just one agent working in a deep linear sequence.
So step 4 takes an hour, step 5 just has to wait.
Exactly.
But workflows are about horizontal width. You aren't looping to check if one thing is done. The script is executing a predefined plan across dozens of items simultaneously.
Yeah, let's ground this with Eddie Chen's YouTube audit from the sources.
Perfect example.
He didn't just ask an agent to review his channel sequentially. The workflow spun up 5 parallel agents. One agent analyzed his specific topic lanes, another ripped apart his thumbnail packaging, another parsed his historical performance metrics, and a fourth looked for strategic gaps in his niche.
And they all performed deep analysis at the exact same time. And then a final synthesis agent merged the data.
Right. The YouTube audit is a great example of fanning out for speed, but where this technology becomes truly disruptive is the deep research capability.
Oh, man.
This is where the swarm moves from simple parallel tasks into an adversarial debate tournament. When you trigger deep research, it doesn't just execute a broad web search. An initial agent dissects your prompt and creates 5 distinct, highly specific search angles.
And it launches those 5 searches concurrently. But it's the verification phase that is so striking.
Yeah, this is the 3-vote fact-checking system.
Right. So when the search agents pull a claim from a web page, say a specific statistic about battery efficiency, the workflow doesn't just accept it. The JavaScript file automatically drafts 3 independent, isolated fact-checking agents.
And it pits them against each other to evaluate that single claim.
It is mimicking a rigorous scientific peer review process, but executing the entire thing in a matter of minutes.
And the logic is heavily weighted towards skepticism. The system requires that 2 out of the 3 fact-checking agents must successfully refute a claim to kill it.
Wait, what happens if it's a tie? Or if one refutes it and the others can't verify it?
Well, if the fact-checkers cannot reach that 2/3 majority to verify or kill it, the claim is flagged as unverified and stripped from the main thesis entirely.
Wow.
Only the data points that survive this adversarial gauntlet make it to the final synthesis phase.
Which completely explains why the token count skyrockets so aggressively.
Yeah.
You aren't just reading an article, you are forcing the AI to host a digital debate tournament for every single line of data it finds.
Exactly.
And we saw this same adversarial setup in the Startup Forge example too. This was the workflow explicitly designed to invent and refine startup ideas.
Yeah, in the Startup Forge, the workflow fans out to 4 separate agents, each tasked with inventing a business idea from a totally different angle: consumer, B2B, climate tech, and AI native.
But they aren't brainstorming in a vacuum.
Not at all. A distinct VC judge agent is evaluating the ideas mid-creation, while idea number 4 is still being drafted. Idea number 1 is already being scored on validated novelty and market feasibility.
But the truly wild part is the stress test phase. The script takes whatever idea the VC judge ranks highest and deploys 3 distinct skeptic agents to aggressively attack it.
And these aren't generic critics either.
Right, each skeptic is prompted with a specific lens, and their only goal is to find a fatal flaw.
Yeah, for instance, if the winning idea is an AI-native climate B2B platform, a skeptic agent programmed as a cynical supply chain auditor might look at it and say, your proposed API calls require 800 milliseconds of latency, which completely breaks the real-time grid requirement of this specific energy sector. The unit economics are unviable.
That level of targeted friction, it moves AI far beyond a simple knowledge retrieval tool.
Oh, definitely. It is an automated boardroom simulator. You are orchestrating a team of highly specialized experts to create, aggressively critique, and refine an output before you ever even see the first draft.
Which brings us to the reality check. Because with this boardroom level power comes massive risk. We mentioned it when we looked at the token burn earlier in our note.
The token burn is real.
Mansell Scheffel ran that deep research workflow on a relatively simple topic: the medical benefits of vitamin C. In just 12 minutes, the script spawned 105 agents and burned through 3.1 million tokens.
And Nate Herc ran a prompt that searched his local desktop files, just 400 files, and it burned through half of his $200 monthly subscription in half an hour.
The danger lies in the architecture we just praised, right? Because a deterministic script is running the show, It does not know what a budget is,
Right, it doesn't have common sense. It just executes the loops until the conditions are met, regardless of how many millions of tokens it takes to satisfy the fact checkers.
which is exactly why the developers built in the YOLO check.
Yes.
The
The
safe-
YOLO check. It's a literal safety pump. Before a massive workflow executes, a warning box pops up explaining exactly how many agents are about to be spun up, and you have to explicitly type yes to confirm.
It forces you to pause before you accidentally nuke your budget.
Right.
But you don't just have to rely on the safety prompt. The sources outline a crucial strategy for surviving the token burn, which is model tiering. I love this feature.
It's essential. You do not need to use the highly capable, highly expensive Opus 4.8 model for every single task in a 100-agent swarm.
Right. The workflow.js file actually allows you to assign different intelligence tiers to different phases of the conveyor belt. So for the 80 parallel worker, tasks like basic data fetching, scraping HTML, or simple brainstorming, you assign the Haiku model.
Because it is vastly cheaper and significantly faster.
Exactly. Then, for the critique phase, like those skeptic agents tearing apart the business plan, you step up to the mid-tier Sonnet model.
Right, because it has the reasoning capacity for logic checks.
And you save Opus 4.8 solely for the final synthesis phase, where it takes all the refined raw data and writes the final polished report.
You just edit the JavaScript file to route the models. It's brilliant optimization. There is a quick warning from the sources, though, about a setting called ultracode.
Oh, yeah, the ultracode setting.
It's a toggle in the interface. If you turn on ultracode, the system automatically defaults to spinning up these expensive, multi-agent workflows for almost any substantive task you give it.
It bypasses a lot of the manual permissions to just give you the best possible answer.
Yeah. And if you leave that on by accident, you will drain your credits in an afternoon.
Definitely something to watch out for.
Yeah.
But, all of this complexity, the JavaScript compilation, the model tiering, the adversarial debate parameters, it raises an unavoidable question for you listening. Does the average user actually need this kind of infrastructure?
I think that's the most important question.
I mean, I have been wondering the exact same thing since we started looking at this, because one of our sources actually brought up a competing tool called Lovable during their breakdown.
Right? Lovable.
Lovable is a platform where you can use simple natural language to build and publish entire websites or web apps with one click. It handles the API keys, it deploys the code. It's incredibly powerful, and it's designed to completely minimize setup for non-developers.
It's an amazing tool.
Right. So if we live in a world where tools like Lovable exist, where I can just chat my way into a fully functioning application, why on earth would I spend my time and massive amounts of money compiling a JavaScript workflow to orchestrate 100 agents?
Because they solve fundamentally different problems.
Okay.
Lovable is incredible for standard deterministic generation. You know what you want, and you just need an AI to write the boilerplate code to build it.
Right.
But you do not use dynamic workflows for standard generation. If you are doing daily knowledge work, general web building, quick single file edits, or even basic automations, you stick to Lovable or basic level 1 sub-agents.
Where's the dividing line then? When do I actually pull the trigger on a workflow?
You reserve workflows exclusively for high-stakes problems that fan out into many parallel pieces of unverified data.
Unverified data. Give me an example.
Like if you have a massive legacy codebase migration where 500 individual files need isolated reasoning, logic checks, and reformatting simultaneously, or say you get complex blood work back from a specialist and you want an AI to scan thousands of pages of deep medical literature from 50 different angles, cross-reference the data, and flag discrepancies.
Wow.
Yeah, problems that require horizontal width and extreme verification, that is when you deploy the swarm.
That is the golden rule to take away from these sources. Look at the task in front of you. Ask yourself, does this task break into dozens of independent pieces that can be executed at the exact same time? And does it require adversarial fact-checking?
Exactly. If the answer is yes and the stakes are high enough, spin up the workflow. If not, save your tokens and use a basic tool.
Because moving from an overburdened LLM manager to a clean, deterministic JavaScript orchestrator is a massive leap forward for AI scaling. But it requires discipline to know when to use it.
It really does.
Well, we've covered the mechanics of a massive shift today. We looked at how Opus 4.8 checks its own internal probability to maintain honesty and how attention dilution forces us to move away from single chat windows.
Right.
We walked up the scaling ladder, examining how workflow.js acts as a permanent memory clipboard, allowing up to 1,000 agents to fan out horizontally. We saw how adversarial swarms use a three-vote system to kill false claims and stress test startup ideas. And we mapped out how to protect your API budget using model tiering.
It is a profound change in how we interact with machines, but there is one final implication of this technology to consider.
Oh, what's that?
We spent a lot of time on that deep research workflow, the
Hmm.
one that spun up dozens of adversarial agents to relentlessly debate, fact check, and require a two-thirds majority to kill a false claim, all in about 15
Yeah,
minutes.
the digital debate tournament.
Exactly. If this level of rigorous multi-agent peer review is now available to anyone with an internet connection and a few dollars in API credits, how is this going to dramatically shift our societal standards for what we consider verified truth on the internet?
That's the huge points.
When an AI can stress test a single claim from 100 different angles, cross-reference every citation, and debate its own findings before you even finish your coffee, the baseline for what we accept as a fact might be about to change forever.